Welcome everyone to today's session on Aspen Hysys. I believe you all can see my screen and you can also hear me clearly. In our previous class yesterday, we talked about or I introduced Aspen Hysys, what Aspen Hysys is all about, what it can be used for. Um, I also told you that Aspen Hysys is a flowsheet simulation. Define what flowsheet is, what simulation is, how this has to relate with um, Aspen Hysys or process engineering. We also looked at our equation of state or our thermodynamic models. We talked about different thermodynamic models we have or thermodynamic packages. We talked about when we need to use Ben Robinson, um, SRLT, and all of that. So in today's class, I'll introduce you to Aspen Hysys software, how it's being used, what it's being used for, and all of that. So currently, I believe you can see my screen. So if you can see my screen, I would like you to drop a comment on this comment section that I can see your screen. I would like you all to do that in 2 minutes. So if you can see my screen, please drop in the comment section. I can see your screen. Okay. Um, I will go directly into Aspen Hysys now. So this is Aspen Hysys window, and this is our welcome window. But the reason it's showing what it was showing is basically because why it's showing this recent and all of that is because I have previous drawing on Hysys. Normally, this is what you are going to see, this blank space. Then this blank space, we have what's new. When you click on what's new, Aspen Hysys is going to open a dialog box. I'm using Aspen Hysys V11, which is version 11. What is new? Aspen Hysys is telling you the modifications or updates that were made in version 11 that is not in previous version. So when you go to general Hysys improvements, you are going to see the general improvements that were made on V11 that you can't find in V10. So we have a lot of them. We also have Aspen Hysys, we have Hysys Dynamics and all of that. Then examples, when you click on it, they are predefined or they are examples that are inbuilt in Hysys. And some of these examples, we have acid gas cleaning, we have activated energy analysis, we have Aspen hydraulics, we have black oil. All these are sample examples inside of Aspen Hysys. We have saltwater strippers. So if you want to go into pressure relief, you want to see a system that has been designed, a pressure relief system, all you just need to do is to click on it. And we have pressure relief benchmark, we have pressure relief starter, we have pressure relief custom, relief load. So you can click on any of them and click on open. When you do that, Aspen Hysys is going to load that data or that file. Just give it a few minutes and those information, the information that has to do with that file will pop up. Okay, so this is for pressure relief starter. Now you can see our feed stream, you can see our valve, the inlet. We have our two-way separator that is going to a heater here, then sent to our compressor, and we have our flow out. Then the liquid is sent to a pump to a valve. We also have another heater here. There are other few informations attached. If we move down, I'm going to close all cases. No. Go back to our example. I will open some other. Okay, we have NLNG plant simulation. Let's open that. Okay, just give it some time. Yes. So this is for NLNG. There are different kind of the reason why these things are here so that you can study them. So if you want to do something similar, you have been given a task to do an LNG plant simulation. So you can use this as a case study or as a guide. No. Okay, then the next we have training. Well, when you click on training, this works for those that have the paid version or the licensed version. You need to log in, and from here you can access a lot of Aspen Hysys trainings from Aspen, all of that. You can access them from here. We also have documentation, models, literature, tools, events. So for the events, if there are upcoming events being organized by an Aspen, you are going to get them here. Announcements, you're also going to get them here also. So this is just basic introduction to Hysys. You click on your file tab. From here, you can create a new file. You can open previous saved file. From here, you can see recent models. All these are models I have worked with or files I have worked on previously. You can easily access them from the previous model section. So in order to start carrying out a simulation in Aspen Hysys, you click on new. We have case, we have templates, we have column, FCC, we have hydro cracker, we have reformer and all of that. Or what FCC stands for fluid catalytic cracker. For case, we need to click on case. Yeah, click on it once. Then Aspen Hysys will load the software for you. Okay, so this is what you are going to see. This is the window where the property window where you set the and every necessary things you need for to carry out your simulation. So please, during this lecture, if you have any question, I would like you to drop it in the comment section. From our previous class yesterday, I'm going to reference that. Just give me a minute. There are a few things. I said when you want to carry out a simulation, there are a few things you need to do, which includes selecting the thermodynamic property, selecting the components that the component involved in that simulation. I will share my screen to, okay, just give me a minute. Okay. I believe you can see um, my slides, the Office document I just opened. Okay. Now from here, I said, Aspen Hysys process simulation model. We can translate a process into an Aspen Hysys process simulation model by performing the following skeletal steps. One, specify the components in the process. We can fetch this from Aspen Hysys data bank. Second, specify the thermodynamic model to represent the physical properties of the components and mixtures. The third is define the unit operations in the process. I asked yesterday what's the difference between unit operation and unit process. No one gave me an answer. So I'm also dropping that question today. If you are part of this class, I would like you to give me a quick answer. What's the difference between a unit operation and a unit process? Please drop it in the comment section. Okay. So the next thing we need to do is to select the define the process stream and all of that. We are going to look at all of this, starting from the first is select the components in the process. Then the second is select the specific thermodynamic property. I'm going to share my screen to Hysys. Okay, this is where you do your setup. Now you make sure you are on property, click on add. No, go back. I need to delete this. I made a mistake. I was on reactions. So make sure that you are on component list at the top. That's the first thing. Click on add. We have lots of components here. We have methane, ethane, whatever components you need for your simulation. Assuming I need water, I can type water here or type H2O here. H2O. H2O. H2O, you can see water, you can see other components or compound that has water in it. So all I need to do is to click on add and that component is being added to my Aspen Hysys component list. I can add these hydrocarbons. I can either click them one after the other, or I can hold my shift key and click on add. They have been added here. As many as whatever you want, just click and add. Now, from what we learned yesterday, I'll click on fluid package, which is the proper thermodynamic property. I need to set that now. I'm going to click on add. Now, we also have the message box, which is at the bottom. It gives you warning whenever, if your simulation is run successfully, you are going to see the warning or the message in the message box. If there are errors, if there are things you need to do, Aspen is also going to notify you. So far, what we have is a required information. That's what Aspen needs, the food package. It says select the proper package, which I'm going to click on add. And remember why we were looking at properties yesterday. I'm going to also share my slide that we talked about selecting, say, specify thermodynamic model to represent physical property. And remember, when what Aspen Hysys was telling us is select the what property package. And I also talked about also talked about the different equation of states. Now I said different thermodynamic property, we have equation of states method. Now this is best for hydrocarbon and gas processes. I'm going to come down to the summary. Okay, rule of thumb, we have natural gas and crude oil. We have Penn Robinson and SRK. So what's the components we selected? Okay, the components we selected, these are what hydrocarbons. They are mostly hydrocarbons, apart from water. So what I'm going to do in this case is so it is either I pick Penn Robinson or SRK. I can use these two property package. So for this, I'm going to use Penn Robinson. After that, my message tab has cleared. So it means I'm good to go from my setup. Then I switch over to my simulation. Now this is where you carry out the main simulation itself, as it has to do with Aspen Hysys. This is where you use your mixer, your heat exchanger, your two-way separator, three-way separator, fractional distillation column, your drum, your pump, your valve, whatever simulation you are supposed to carry out. This is where you carry out the simulation. So this is my model palette. This is my model palette here. The model palette contains the icons that represent each of these units operation. Remove my palette this way. Now, my model palette, you have our feed stream and we have our energy stream. Feed stream is simply where the feed, where you specify the inlet to any component, your feed, specify the inlets and also the outlet or material stream. We can also call it material stream. Yeah, material stream. So it's either the inlet or the outlet. That's basically what the material stream does. So select inlet 1, outlet So basically, this is it. The inlet stream and the outlet stream. I'm going to click this. Okay, so with that, um, I'm going to do few examples. Then, before I dive into that, I'm going to look, show you guys how to set your unit. So we have units here. You can click on unit set. From here, you can define your own units if you want to add your units. Um, these are the predefined or the units you'll be using attached to each of these, whatever you're doing. So these are the units. From here, you can change yours if you wish or if you want, but I'm not doing any of that. So all what you need to do is to come down here and you can either use SI units, you can select any of these, you can use European SI unit, you can use safety EN, English, and whatever. So I usually leave mine in SI units. And okay, we are going to take one example. I will share my screen. Um, share my slide. We are going to look at a very simple example. Please, if you have questions, I would like you to ask. If you're also online, please can you indicate in the comment section so that I know those that are following this class. Please, if you are online, type on the comment section, I am online. Okay, so we are going to take few examples on this. And the first one we have here is a mixer, which is blending two water streams. Now, this is the problem statement. Two water streams are mixed. Stream one, we have the property, 30 degrees C and the flow rate is 5 kilogram per second. We have stream two, 80 degrees C and 10 kilogram per second. We are asked to determine the temperature of the mixed stream, that's the outlet stream of this stream. Okay, what I will share my Aspen Hysys screen now. So the first thing I need to do is to, bring in my material stream. This is my material stream. And I'm going to bring up another stream. I'll double click on this and name this stream one. Stream one. Double click on this, name this stream two. Okay. From here, I'm going to click on my mixer. Remember our example, we are looking at our mixer. Then I'm going to name this one mixed stream. You can also name this one as my mixer. Okay. Um, from my message dialog box, you can see that it's giving me an error, not solved, unknown flow rate, unknown pressure, unknown, a lot of unknown. So there are a lot of things we need to specify. From our inlet here, you can see the inlet here. I'm going to specify the inlet, which is stream 1. And you can see a preview. Stream 1 has been attached to the mixer. Stream 2 automatically has been attached to the mixer. My outlet is mix stream. Now, I also have another caution sign. It says not solved. Not solved. Why is it not solving? I can read my message dialog box again. It says unknown what flow rate, not solved. Mixer, mix stream, which is this mix stream, has not been solved. So the first thing I need to do is to double click on my stream 1 and specify it. You know that temperature for stream 1 is 30 and flow rate is 5 kilogram per second. Temperature is 30 degrees. So from here, you can change your preferred unit. And flow rate, which is mass flow, and we have 5. I'm going to change this to kg per second, kgs. There was no specific pressure, so I'm just going to use 1 atm. 1 atm. Now it says unknown what? Composition. Unknown composition. In order for me to set my composition, which is the reactant and the product, or the composition of the entire feed or stream. Now these were the components we added. From our example, what we are working with is just water, purely water. So from here, I'm going to use water as 1, hit enter, and every other thing is going to be 0. Okay. So water is my major component, every other component here is 0. Now you can see that it's showing me okay, meaning it has been solved. My material stream is okay. Stream 1 is okay. I'll double click on stream. I'll come to composition again, double click, or click on edit, hit 1, hit enter, click on OK. 1. Now it says unknown temperature. Condition temperature here is 30 degrees C. Hit enter, pressure. I'm going to use 1 atm. And the mass flow is, for this is 10 kilogram per second. Now you can see it says okay. It has been solved. That stream has been solved. Now I don't have any error message again. Everything is clear. And initially this was yellow. Now it has moved to blue. Whenever you see that this is blue, it means your simulation has been solved. You don't have any error, no warning. Okay, now let's look at the temperature. Or what, for me to get the temperature of this, what I need to do is to click on the mix stream, this, right click, and click on show table. Okay, so from this show table, you can see the temperature out. The temperature out is 30.0. The pressure is 101 kilopascal, and the molar flow is this. So I can, all I did was double click on this, and I can also add more variables here if I want. I can maybe um okay, I have the molar flow here already. I have temperature, I have pressure. Okay, I can look for mass flow, molar flow. Okay, let me just add mass flow to this. Okay, done. So this is the mass flow close. It has shown here. So from this, I can decide to change the representation of all this. Give my pressure or come to units and search for pressure P. Okay, okay. Pressure is in kilopascal. I can change that to ATM. Then close. So you can see here the pressure is 1 ATM. So what we have found out that when these two streams mix, stream one, which is 30, stream two is 30, stream two 30. Okay, stream two is 80. Um, double click on this. Stream two is supposed to be 80. Enter. Okay, now you can see that the temperature has changed to 63.39 degrees C. Still maintain the same pressure and mass flow. So this is how you carry out simulations in Aspen Hysys. You are going to look at some few other examples from here. Also, I can right click and show table and know the stream composition of all this. Okay, I'm going to look at another example, which is the splitter. I'm going to look at about 3 examples before the end of this class. I believe you all can see my screen now. The next example I want to treat has to do with splitter. The first example we did was mixer. We looked at mixer and There are a few other examples we are also going to take along the way. But for this, we are just going to look at simple examples that are not complex and straightforward for you to understand. So please, if you have questions, do not hesitate. Um, Drop your question in the comment section or go to the WhatsApp group. We have the second group, which is for software installation. Please go there and drop your question so that I can address it. So for those of you that are not in the software installation group, I'm dropping the link there. Okay. All you need to do is to go there, click the link, and ask your question. Okay, good. Let's look at our second example. A splitter, basically splitter is used in dividing the flow. We have one inflow and we want to divide this flow to go into different segments or sectors. Okay. So what we need to do is to split that stream, and we do that using a splitter. We have a water stream flowing at 100 kilogram per hour. The temperature is 60 degrees C. Is split into two equal parts. Verify that the outlet stream have the same property as the inlet stream. So from here, the steps: use water as the fluid package, add no. Okay. Add splitter from the unit operation, connect the stream, all this, we know that. Let's move over to Aspen Hysys. Share the Aspen Hysys screen. Okay, so what I'm going to do is to click on new case. Yeah. From this, we click on components and just add water, H2O, add. Click on fluid package, add. I can use NRT or Uniquac, whichever one. Then switch to simulation. My material stream, double click on this. I'm going to name this feed. And from what we are given, our feed stream has a temperature of 60 degrees C, 100 kilogram per hour, 60 degrees C, 100 kilogram per hour, which is the mass flow, 100 kilogram per hour, hit 100, hit enter rather. Going to use one ATM, hit enter, 60 degree, hit enter. Unknown composition, just like before, our previous example, come to composition, click on edit, and one, fully specified. Click on OK. I'm going to click on the T, that's the splitter. Now you can split this into more than one fraction. So for this, I'll use outlet 1. Outlet 1. It says unknown composition also. Double click on this. Type outlet 2. For this also, double click on this. Come down to my inlet. Here is my inlet. What is the inlet? That's the feed. The outlet, I have 1, I have 2. Now, when I use 1, it shows me this green, the green sign, which is okay. But the moment I use 2, it says unknown split, meaning unknown split fraction. I need to specify the split fraction. My feed is well specified, but my split fraction for this has not been specified. Now, what it means is there are 2 outlets from my mixer. These 2 outlets can carry different amounts of the product. So I might decide to say that, okay, stream A, outlet 1 is going for export, so it needs to carry more products, and outlet 2 is for local content. Then I can say, okay, let 60% of whatever I'm getting from my feed go to outlet 1, then 40% go to outlet 2. So it depends. If I have more than 2 streams, I can specify it. I can say, okay, 25%. Let's assume we have 4 streams. I can say 25% goes to stream 1, another 25% goes to stream 2, 30% goes to stream 3, 20% goes to stream 4. It all depends. So in order for me to specify that, I'm going to double click on my T, go to design, click on parameters. Now I have flow rate. The degree of freedom here is 1. Whenever the degree of freedom when working with Aspen Hysys is the number of is basically n minus 1. So we have the number of outlets. The number of outlet streams we have here is 2, n minus 1. 2 minus 1 is 1. So the moment I specify, let's assume 0.6, Aspen Hysys automatically calculates this, which is 0.4. Or I'm going to use 0.5. I'm going to delete one first. Delete one first. Delete this and use 0.5. Okay. It calculates the other one. Our question says, okay, run the simulation and check the property of the outlet streams. Verify that the outlet streams have the same property as the inlet stream. Let's verify that. First of all, let's check the properties. Show table. Show table. Show table also. Okay. So outlet 1, we have temperature C, pressure 180 molar flow 2.775. The same thing, because the 2 outlets are the same. Note our split fraction was 0.5, which is equal. If I modify what I have here, delete, use 0.7 here. Now you can see my molar flow for this is 3.886. Molar flow here is 1.665. Molar flow here is 5.551. Temperature remains constant, and pressure. Okay, please, if you have any question with regards to what I just did, I would like you to drop your question. Drop your question. Okay, please give me a minute. Let me take water. Okay, no question, meaning it's well understood, right? Okay, so the um, next example we are going to look at is heater. So heating water from 25 degrees C to 100 degrees C. Problem statement, a heats a stream of water from 25 to, then we asked to determine the heat duty. Okay, I'm going to share the other slide. I have some other examples which I would want to share. Okay, so we also have this mixer. We have water here, 100 kilogram per hour is the mass flow. We have 3 inlet stream and one outlet stream. This is supposed to be a splitter going out, supply 1 to 3. We also have a pump, something like this. Okay, let's do this. Let's work with this mixer. Are you all following, please? Okay, so from this, I'll share my screen to Hysys. Excuse me. We also have water. My property, I'm going to add water. H2O. Add. Property package. For this, we have S. Okay, we have SRK. Okay, we have SRK. The assumed pressure is 1 atm or 1 bar. I'm going to use SRK. Specify that. Switch to my simulation. Okay. We have my mixer. Stream 1, stream 2, stream 3. Double click this. We have supply 1. Supply 1. This supply 1 has water is okay, the three of them has the same composition or property. 1000 kilogram per hour. That's the mass flow. 1000 kilogram per hour. 80 degrees C. Pressure 1 atm. Then come down here, our composition, type 1. Okay, fully specified or fully defined. The next thing I need to do is to double click on this and click on define from stream. What I'm going to do now is select on supply 1 and select OK. Select, double click on stream 3, supply 3. Come down, define from stream, click on supply 1. Now you can see that this, so what I'm doing is, instead of me repeating what I've done in supply 1, supply 2, all I just needed to do is to define it from that stream. So what Aspen Hysys does is it grabs the properties. So when I do that, I click on supply 1. You can see copy stream conditions, temperature and pressure. You have composition. So whichever one you don't want, you can click on uncheck those ones and click on OK. Then I'll double click on this and rename this to supply 2. Next thing I'm going to also do is to click on this. I'll name this mixed out. Double click, select my inlet stream, supply 1, supply 2, supply 3, mix out. So you can see showing what blue, fully defined. Fully defined. So the next thing I want to do now is to split it. Use my splitter to split it into 3 different outputs. Okay. So I'm going to call this line 1. I'm going to call this line 2. I'm going to call this line 3. Remember the first example we did, we used only 2 lines. So from this, I'm going to use my inlet, which is mixed in. You can see it's mixed in. Then 1, it automatically defines, but the moment I add these 2, it shows me unknown splits because Aspen doesn't know. I haven't given it information on how I want to split the flow between these 3. So I'm going to double click on this, go to parameters. For this, the degree of freedom is 2. So I will say 0.5 to stream 1, then 0.2, which is 20% to stream 2. Okay. Now, this is fully defined. So you see that Hysys is not, it's not difficult to learn, actually. Hysys is not difficult to learn. Very easy. Okay, so I don't know if you have any question, whatever, but this is where we are going to come to conclusion of today's class here. On Friday, which is our next class, we continue from where we stop. We are going to look at a few other examples like pump, heaters, compressor. Yeah, we're going to look at pump, heater, and compressor in our next class on Friday. Thank you for participating.